Hey guys, welcome to LeetCode. Today we're going to talk about our third LeetCode algorithm problem, LeetCode number 482, license key formatting. So it's a very basic problem, but it's very popular recently. It got frequently asked by some companies. So as always, I'm going to provide not only the solution, but more importantly, what are the interviewers looking for when they give you this problem? So let's get started.
So the problem is you're giving a license key represented as a string S, which consists only of a numeric character and dashes. The string is separated into n+1 groups by n dashes. Given a number k, we would want to reformat the string such that each group contains exactly k characters except for the first group, which could be shorter than k, but still must contain at least one character. Furthermore, there must be a dash inserted between two groups, and all lowercase letters should be converted to uppercase. So let's see the example. The input is string 5F3Z2E dash 9 dash W and case 4. So the output is 5F3Z and 1 dash and 2E9W because the case 4. So every key every 4 characters we want to have a dash inserted, but we don't want any dashes, any dash in the front of the string or at the end of string. So the example 2-5G-3-J case 2, and here is output. Well, that's problem. So first, I want to discuss the most popular solution under LeetCode discussion board. The basic idea is to simplify the string first and then insert dashes as we want. Because we don't care about the dashes in the original string and we want all the characters to be uppercases. So we simply remove all the dashes, can make the string all uppercases first. For the task, it's just 5F3Z2 uppercase, E9 uppercase W, and then we insert the dashes from the back at every k position. For example, case 4, we go from the back 1, 2, 3, 4, insert a dash. The solution is very straightforward. Let's see how to implement it in Java. First, replace all the dashes in the original string with empty string to remove the dashes, and then make them all uppercases. Second, make string S a string builder SB. Length is the length of this string builder. Then the most important part, inserting dashes from back at every key position. So loop from I is length minus k to I is bigger than 0. And I add k for every round. We do it from I is length minus k instead of length because we don't want a dash at the end of the string. If we do it from length, there will be a dash at the end of the string. We iterate I to bigger than 0, not to 0, because if we iterate I to 0, there will be a dash at the beginning of the string, and we don't want that. So inside the loop, just insert a dash to index I. Don't forget to convert the string builder to string before returning it. Did we forget something very important? Time complexity and space complexity. So space complexity is very straightforward, just ON, because we used a size n string builder. How about the time complexity? So I went over the comments in LeetCode discussion board. Apparently, a lot of people just assume the time complexity is ON, but let's walk through the code. First, s.replace and s.uppercase. Ideally, the time complexity here is ON, and then creating a string builder with string s on. and then looping the string builder at every key position, O n divided by k. However, inside the loop, stringbuilder.insert is actually taking on time, not O1. So the time complexity for the loop is n divided by k times n equals to 1 kth times n squared. So the overall time complexity is absolutely bigger than on. For coding interviews, interviewers do not care about what programming language you use. But whichever language you choose, you have to know the performance of the libraries you use. Now let me explain to you why Java string builder insert takes on time. String builders in Java are implemented by char arrays. For example, let's initialize a string builder. Somewhere deeply in Java is a char array like this. Now the tail is index 0. If we start to append characters to the array, the tail pointer moves accordingly. So string builder append only takes time of 1. However, when we want to insert a dash in the middle, what Java does is for us, it makes a copy of the second half and then add the dash, and then copy them back after the dash. Because array is not a linked list, we can never do inserting with a one time. So the time complexity for string builder insert is on. Remember, we mentioned in previous episode that when we try to find the optimal solution, try to think that what's the lowest time complexity possible for this problem. It's usually our goal. So the lowest time complexity possible is on here. I think it's very obvious. So how can we achieve the on time complexity? Let me share with you my on solution. It's also very straightforward. We can simply iterate the string from back to front. If we run into a dash, just ignore it. Otherwise, we make the current character uppercase. And in the meanwhile, I want to have a variable to count where are we in size k section. So when the count reach k, we can add the dash. For the test case, we go from the back and we have the string builder as b, and then the count. First, we have a character lowercase w, make it uppercase, and add to the string builder. The count was 0, and now it's 1. And then a dash in the original string, just skip it. And then a number 9, add to the string builder, and the count was 1, now 2. And then another dash, skip. And then lowercase e, make it uppercase, add it to the string builder. The count is 3 now. And then the number 2, add to the string builder. The count becomes 4. Notice that we reach k now. We need a dash here. So add the dash, the count is back to 0. And then similarly, dash, skip it, uppercase D, add to string builder, count plus plus. Number 3, add to string builder, count plus plus. Then uppercase F, add to string builder, count plus plus. Finally, a number 5, add to string builder, count plus plus. The count is 4 again, so add a dash to our string builder and set count back to 0. Well, after the loop, it's possible that we will have an extra dash at the end that we don't want. So check if the character at the end is a dash. If it is, remove it. Don't forget to check if the string builder is empty before you do that, because if it's empty, there will be no character at the end. The last step for this solution will be reverse the string builder and return it as a string. Let's discuss the time and space complexity for this solution. Space is on because we used a size n string builder. How about the time complexity? So the loop takes on time, and inside the loop, string builder append takes O1, so overall ON for round 1. For round 2, string builder reverse actually takes ON and the toString also takes ON, so the overall time complexity for the solution is ON. Let's try the two solutions in LeetCode to see if the performance of solution 2 is truly better than solution 1. Run solution 1. The runtime is 244 milliseconds. It only beats about 28% of Java online submissions. But if we run solution 2, the runtime is only 24 milliseconds, and it beats 88% of Java online solutions. If you wonder, our solution 2 only beats 88%, what kind of solution can have the best performance? Let me show you something from a LeetCode discussion board. This solution uses char array instead of string builder. The time complexity is also OM, but technically lower than our solution 2. And this solution beats 98% of Java online submissions. As we can see, it is a relatively complicated solution. For an easy level problem like license key formatting, we typically target to solve it within 15 minutes because interviewers probably prepare more problems for you to solve for the rest of the time. I personally don't think a solution optimal like this is necessary during interviews. If you are not confident solving the problem using the optimal solution within your interview time, just go with the solution that you are most comfortable with. Remember, any solution is better than no solution. The same logic applies to real-world problems too. In industry, we deeply care about the performance of the code. However, we care about the effort engineers put just the same or even more. At Facebook, people value done is better than perfect. We can see this poster everywhere in the company. I believe it's also the way to go for coding interviews. Unless the interviewer specifically asks you to find the optimal solution, which is not very common, done is always better than perfect. Do what you feel confident first and then optimize it if there is time left.
Well, that's all about our LeetCode number 482, license key formatting. I hope you have a better understanding for what interviewers are looking for in a coding interview after this video. Programming languages do not matter. Whichever language you use, own it like a pro. Know the performance of the libraries. Thanks for watching. If you like my video, please subscribe, like, and comment. This is LeetCode. I'll see you next time.